The reason for using an inferential test is to get a probability value, commonly called p-value. The p-value provides an estimate of how often we would get the obtained result by chance if, in fact, the null hypothesis is true. In statistics, a result is called statistically significant if it's unlikely to have occurred by chance alone. The most commonly used standard or cutoff is 0.05 or 5%. Because this standard or cutoff is so important, it has a special name. It's called the significance level of a test and is usually denoted by the Greek letter alpha. So alpha equals 0.05. If the p-value is small, less than 0.05, this suggests that it is more than 95% likely that the association of interest would be present following repeated samples drawn from the population, aka a sampling distribution. If the p-value is less than alpha, which is usually 0.05, then the data we got is considered to be rare or surprising enough when the null hypothesis, H subscript 0, is true. And we say that the data provides significant evidence against the null hypothesis. So we reject the null hypothesis and accept the alternate hypothesis, H subscript A. If the p-value is greater than alpha, then the data is not considered to be surprising enough when the null hypothesis is true, and we say that our data do not provide enough evidence to reject the null hypothesis, or equivalently, that the data do not provide enough evidence to accept the alternate hypothesis.